Imagine standing in front of a mirror. Not just any mirror that bounces back your reflection, but one that pierces deeper than sight, bending not light but time itself. You look, expecting to see your own familiar face staring back, and instead you see the beginning of everything, the trembling infancy of the cosmos, when space was still stretching its newborn arms, when matter itself was learning how to exist. That was the promise of the James Webb Space Telescope, to become our ultimate time machine, a golden-eyed instrument that would peel away the darkness and let us glimpse the first flickers of creation. But what it found when it gazed farther than anything before it was not simplicity, not chaos, not the crude building blocks of a young universe. What it uncovered was something far stranger, a contradiction so sharp it cut through the very assumptions of modern physics. It saw the impossible, mature, structured galaxies existing billions of years too soon. It did not reveal the universe's cradle. It revealed a cosmos that looked as though it had skipped childhood altogether, leaping directly into complexity, and in doing so, it shook the very skeleton of science itself. For decades, our understanding of the cosmic story seemed fairly steady. First came the Big Bang, a violent release of energy and matter. Then followed the Dark Ages, a vast gulf of emptiness, with particles drifting, waiting, cooling. Eventually gravity began its patient work, pulling hydrogen and helium into clouds, igniting the first stars. Slowly, painstakingly, those stars died, exploded, and spread their elements, giving rise to galaxies, planets, and eventually the strange phenomenon of life. The further back we looked, the simpler things should have been. Faint hydrogen mists, primitive particles, the quiet rumblings of order trying to form. And yet, when Webb turned its golden mirrors to what astronomers thought was just an empty stretch of sky, a piece of darkness so vast it was expected to yield little more than silence, it captured something that should never have existed so early. A fully developed galaxy. Not a smudge, not a faint echo, but a magnificent, rotating system of stars. It had spiral arms. It had tightly bound clusters orbiting in balance. At its center roared a massive black hole. This was not a child of the cosmos. It was an adult, thriving where only infancy should have been possible. And it didn't stop at one. With each new observation, Webb uncovered more of these impossibilities. Galaxies were appearing fully formed, chemically rich, gravitationally stable, all at a time when the universe was supposed to still be fumbling in the dark. It was as though the cosmic clock had leapt forward billions of years in the blink of an eye. To scientists, the implications were devastating. If galaxies could form so quickly, then perhaps everything we thought we knew about the pace of cosmic evolution was wrong. When astronomers analyzed the light from these galaxies, the delicate fingerprints embedded in their spectra, the shock grew deeper. The galaxies weren't just made of hydrogen and helium, the simple ingredients born in the Big Bang. They contained oxygen, carbon, even iron, heavy elements that can only be forged in the hearts of massive stars. Those stars had to live, burn, die, explode, and scatter their ashes across space before such elements could exist. And yet here they were, in galaxies less than 400 million years old, displaying the chemical scars of not just one, but multiple generations of star death and rebirth. The early universe, it seemed, had not woken up slowly. It had erupted, sprinted, collapsed, and reformed in a fever dream of creation. This was not supposed to be possible. Imagine planting a seed and returning a few hours later to find not just a sapling but a towering ancient tree, its branches already stretching skyward, rings upon rings carved deep in its trunk. That was the scale of contradiction Webb had delivered. And then came the most shocking discovery yet. Deep within one of these galaxies lay a monster, a supermassive black hole, weighing 1 billion times more than our Sun. Even in today's universe, such giants are rare and difficult to explain. But in the first 400 million years after the Big Bang? That was beyond improbable. Black holes are thought to start small, as the remnants of collapsed stars, growing over billions of years by consuming gas, dust, and stars unlucky enough to wander too close. Yet this one seemed to have skipped growth entirely. It hadn't crawled its way upward, it had arrived fully grown, like an adult born an hour ago. The implications were staggering. Had primordial black holes, predicted only in fringe theories, formed instantly in the chaos of the Big Bang? Did exotic matter or unknown particles accelerate their growth at impossible speeds? Or was there some deeper mechanism, one we have yet to imagine, that allows gravity itself to cheat time? As if this wasn't enough, Webb began to reveal patterns hidden in the very structure of the cosmos. Using advanced algorithms, scientists found that these galaxies weren't scattered randomly. Their positions echoed a mathematical rhythm, repeating ratios eerily similar to the golden spiral, the same geometric pattern seen in seashells, hurricanes, even the spirals of sunflower seeds. This was no mere coincidence. It suggested that matter itself, from its earliest moments, followed a fractal blueprint woven into the bones of spacetime. Was this just physics wearing the mask of beauty, or something far stranger? A design, intentional or otherwise, that imprinted itself across billions of light years. Then came an even more unsettling revelation. Webb's instruments detected faint chemical traces drifting in what was thought to be empty intergalactic space. These weren't simple molecules like methane. They were complex organic compounds, the building blocks of amino acids, the seeds of life itself. They were just floating there, suspended for over 13 billion years. If these molecules existed so early, it meant life's ingredients weren't an accident of late-forming solar systems. They were part of the universe's fabric from the very start, distributed like cosmic pollen waiting for worlds to catch them. Life, in this view, wasn't an anomaly. It was inevitable. And then came the discovery that left even hardened scientists silent. Among a cluster of ancient galaxies, Webb detected something too symmetrical to dismiss. 6 galaxies perfectly arrayed around a central core, spaced with near mathematical precision, moving in a synchronized orbital dance. It looked like a flower carved into the darkness, petals of starlight circling a cosmic heart. Astronomers called it the flower, but the explanations fell flat. Gravitational lensing? Perhaps. Statistical fluke? Possible, but unlikely. A relic of some unknown early universe physics? Maybe. And yet, a quieter question lurked. What if this was no accident at all? What if it was a message, a marker left behind in the fabric of space, waiting billions of years for us to finally be able to see it? As unsettling as these mysteries were, perhaps the most chilling theory came not from what Webb observed, but from what its observations might mean. In quantum physics, the observer effect tells us that the act of measurement can change the outcome. But what if this doesn't stop at particles? What if the universe itself, on some unfathomable level, responds to attention? What if, by building Webb and peering into the deepest past with unprecedented clarity, we didn't just uncover hidden truths, we altered them? Some researchers now whisper about images that shift subtly as data is reprocessed, as though reality itself is reacting to being seen. Could it be that the universe is not just a stage we watch from the sidelines, but a story that rewrites itself as we turn the pages? If that's true, then we are not merely observers. We are participants, co-authors in the unfolding of reality. Webb didn't just find galaxies, black holes, or molecules. It found a mirror reflecting not just the past, but our role in it. It found a cosmos that may be aware of our awareness, a universe that whispers back when we dare to listen too closely. So now the question isn't simply, what did Webb see? The question is, what saw Webb? And if the patterns feel too sharp, the timing too precise, the revelations too synchronized to be random, you're not alone. Maybe the universe was never silent. Maybe it has always been waiting. And now, with Webb's golden eyes, we finally heard its first reply.